is 2, 4, I think.
It's not one of the problems. It's a general question. You said we have to do 70% of the homeworks.
No, you have to get a grade of 70%. Not you have to do 70%.
A grade of 70%.
The grade for every assignment before class has to be 70%. Then you have time till February such and such to raise your grade if you want to.
Okay, so we're still gonna keep the 70. We just need to raise it later.
You can even have 100 already, or you can raise it whenever you want. 70% is good enough for me.
I understand.
Only because I want students to contribute to the discussion, to ask questions. If, let's say, Haley asks a question and you are in the know because you did your work and you know what she's asking. Good. Anything else? Are we working on anything else? Other questions? Anything? Anything? Well, in that case, we're going back to, I have the book already open in the background. And where are you guys? You're here. Okay. So we looked at situations like these. These are all very friendly. All we have to do, they're all polynomials. Polynomials never have an issue. So if I want to determine the limit as x approaches 5, I just plug it in and that's a number, I'm done. With rationals, we talked about that. We had some examples with rationals. If 3 is in the domain, and it is, there is no problem. I'm going to have a number here. Okay. Now, I would like to talk about the next set, which is a totally different situation. So let me explain something before you choose, I choose. Okay. We already established that a number that is not 0 over 0 is no hope. Ever, ever, ever. Which means 3 options. Only one. Negative infinity, infinity, D and E. And you have to choose, and you have to choose only one. Okay. But what happens if I have 0 over 0? 0 over 0, which is not here, right? This is not 0. Not 0. 0 over 0 has hope. Notice that I didn't say the limit exists. No. I only said there is hope. There are chances that the limit exists. Okay. So I'm going to start. So there are many, many situations here. This, by the way, this, as we know from algebra, this is called undefined situation. Undefined. This has a totally different name. It has indeterminate. And there are 7 cases. No, we are not going to discuss all 7 here. We're going to discuss a few of them, not all 7. In 191, in the STEM calculus class, I go over all cases. But here we have only a few. Okay, so this is an indeterminate case, which means anything can happen. Here it's very clear. There is no hope, and these are the only possibilities. Here, I said it has hope. Can it end up with this? Yes. Yes. Hope can end up with negative infinity from yes, it has hope to no hope. Yes, it's possible. So this can end up here, it can end up here, or can end up here. But at the same time, the answer can be anything. It can be negative 500. It can be 0. It can be 1500. It can be really, really anything. That's why it's called indeterminate. So how do I address these? With a lot of algebra, maybe rationalizing, maybe simplifying, maybe factoring, who knows? There are many, many situations. So now let's choose. Allow me to choose first, and then you choose. So let's say I'm going to start with, I don't know, 21. In 21, we have limit as x approaches 1. from x squared plus 5x minus 6, everything divided by x squared minus 1. You gave me this limit. I know I picked it, but you can pick the next one. So I'm looking at this. I have no idea what this is. But I will know after I plug it in. This is mandatory because I have no idea what this is going, where this is going. But once I plug it in, I'll have an idea. 1 plus 1 is 5. 1 plus 5 is 6. 6 minus 6 is 0. 1 minus 1 is 0. So I'm in this situation. Does the limit exist? I have no clue. But it definitely has potential. It's not closed up like this one. Good. So in this case, normally with rational functions, I'm going to try to factor. And look at what happens here. If I do this, if I subtract 1 from both sides, what I'm really telling you is that x minus 1 approaches 0. If I manage to eliminate from here a factor of x minus 1 and from here a factor of x minus 1, the limit has chances of existing. If I cannot eliminate the 1 from the denominator, there is no way I can find the limit here because there is none. So my hope is that this, because this is the culprit. This is the culprit. If I can remove it from here and remove it from here, the 0 over 0 goes away. Unless it's x minus 1 to the third power and so on and so forth. So there are other options, other situations. Okay, so can anyone factor the numerator, the denominator? Can anyone tell us? Definitely it has to have an x minus 1. How do I know? Because I got 0 over 0. At least one factor of x minus 1 is in the top polynomial and 1 in the denominator. Absolutely certain. But I have to determine the other two. Can anyone give us a hint?
The top would be x plus 6.
X plus 6. And the denominator?
X plus 1.
X plus 1. So this is very clear. Here, if you want to check, x squared minus x plus 6, 6x is indeed 5x, and negative 6. Now, remember, I can simplify only factors. Do not attempt. That would be a terrible mistake. I'm going to write it and delete it. I mean, erase it. So this, doing this, will be an absolute terrible mistake because this is a term and this is a term. We cannot simplify terms. We can only simplify factors. So once I factor, this is a common factor, it goes away. So now the simplified form is a friendly situation. Because now 1 is in the domain of this function, I'm done, 7 over 2, there is nothing else. So, what did I do now here? I realized that it was a situation that had hope, no guarantee. It has hope, no guarantee. But I was able, when I realized that when I plugged in 1 and I got 0 over 0, I knew that this is the problem. And if I can eliminate it from the top and the bottom, especially from the bottom, then the limit will be a number, which means the limit exists. Any questions on this problem? Any questions on this problem? Okay, so let's look at another one. Like, for example, 27. In 27, there is a different issue. So 27. So we have limit as x approaches 9. 9 minus x over the square root of x minus 3. Yes, when I plug it in, I get the same thing. 9 minus 9, 3 minus 3. And of course, my hope is that this goes away somehow. In this situation, we have to rationalize the denominator. In rationalizing the denominator, that's why we reviewed the first thing we did. We reviewed these three formulas, and one of them is this. Does anyone remember? You already factored it for me. Does anyone remember what this equals to? This was our first lesson 2 weeks ago.
That's a squared minus ab.
This is the difference of squares. This is not a binomial squared. It does not have three terms. This is the difference of squares. This is what we have to use here. I'm going to write the limit one more time because I already have the equal symbol here, and that's in the way now. So limit as x approaches 9 from either side, 9 minus x, the square root of 3, the square root of x minus 3, sorry. Okay, so we need to use this formula and rationalize the denominator. So you see, the denominator is basically this piece, the square root of x minus 3. Well, I need to multiply by the square root of x plus 3, because the square root of x minus 3 times the square root of x plus 3 will be the first term squared minus the second term squared. And that's what I want. So this is again limit. Stop me if you have questions, please. This squared is x minus this squared is 9, because I used this formula where this is this piece, this is this piece. When I multiply them, I have the first term squared minus the second term squared. Now I have to deal with the numerator. But first I want to factor out -1 here. So I have x minus 9 and the square root of x plus 3. Let's stop for a moment. Do you understand this step? Is this clear? Please say something. Anybody, please.
I'll be the one to say I'm a little lost.
Which part?
I don't get the first step of factoring out the x squared plus 3.
X squared plus 3. I'm not sure. I don't.
Sorry, not that part. Sorry, not x squared. The square root of x plus 3.
So I have this here. I need to use this formula. I have this. So then I need the conjugate. Only a minus b times a plus b will be a squared minus b squared. So if the denominator is the square root of x minus 3, I need the square root of x plus 3. When I multiply these two, I get that. Is that better?
Yeah, I think so.
That's why we reviewed this formula on the first day of classes. We reviewed this formula and two more. The a plus b squared and the a minus b squared. Is that okay? If I had the square root of x plus 3, I would have used the square root of x minus 3 because this product gives me that in any order. So the denominator was the square root of x minus 3. I needed the conjugate. If I use the square root of x minus 3, then this product will have 3 terms. So I did not eliminate the square root. In order to eliminate the square root, I had to use the conjugate. Is that better? Please say something so I know if I can continue, or
I think so.
is it better?
Yeah, I think so. I can understand that.
So I have this, so I need the opposite. I shouldn't say the opposite, it's called conjugate. When I multiply these two, I get that. It's the only way to eliminate the square root. And I already know from the beginning what I need to get rid of. And here it is. Is this okay? Please say something. I don't want to lose anybody. Is this okay? Yes? No? Anybody? Okay. George, is this okay? Okay, George said okay. Daisy, are you okay with this?
Yes, I'm okay.
Okay. So then I continue and I have limit as x approaches 9 minus this one. I cannot forget about it. The square root of x plus 3. I plug it in. The square root of 9 is 3. 3 plus 3 is 6 with minus in front, negative 6. And the limit exists. Is this okay? Okay, so let's look at one last form, which appears to be a little bit more difficult sometimes. So I'm going to try to make it as simple as possible. So let's look at 31. This is a different type. In 31, we have limit as x approaches infinity from 5x minus 2 over 4x plus 1. Okay.